Hello, my dear students. Welcome to lecture number 2 on force and Newton's laws of motion. In the previous class, we were discussing effects of force. We will continue the same part in this session of the lecture, along with some other concepts such as balanced and unbalanced forces. So let me begin. The another effect of force, that is, it can change the speed and direction of a moving body. A force can change speed as well as direction of a moving body. To illustrate that, when a hockey player hits a moving ball, just in this picture you will get the former Indian captain Sardar Singh is trying to move the ball here against the team Pakistan. So when a hockey player hits a moving ball like this, the speed of the ball either decreases or increases. The speed of this ball either increases or decreases, and hence I can say that force can change the speed of the object. So similarly, if we pass to some other his teammates, probably we are not getting his teammates in this picture. Anyway, if he passed the ball with his teammate, its direction is going to change. Assume there is a person somewhere here, he can push up the ball somewhere here, then we can say easily that it can even change the direction of the moving body. Here the body which is in motion is the ball here. And similarly, we have one more example, that is when a bowler bowls to a batsman. A bowler bowls to a batsman with some speed, and batsman changes its speed of the ball along with the direction. In this picture, Virat Kohli is batting. So a bowler from Afghanistan is bowling at. So here, when he delivers the ball, what happens? The batsman tries to place the ball wherever he wants. So I can say that a bowler which he is probably moving with some speed of say 130 km per hour, that 130 km per hour speed will not remain same here, because the batsman either pushes or cuts or pulls, whatever it may be, but the speed along with the direction changes, and hence I can easily quote that the force can change the speed and direction of the moving body. I hope you got this point clear. One more effect of force that is most important, that is it can change the shape and size of the body. A force can change shape and size of the body. To illustrate that, we have some examples here. A bottle can be squeezed with muscular force. In the picture number 1, you will get a bottle which is squeezed here with the help of muscular force. Means the muscular force is the force which is now in this example is squeezing the bottle. Okay, that is the first example. Similarly, we have second example, a force acting on dough when we roll chapati or roti. So whenever you are doing or whenever you are rolling a chapati or roti, you are having the dough. So for that you need to give some muscular force to that. By that it can change its shape and size. So this is the second picture showing for this particular example. And in the third example, the accidents make vehicles crash. So looking into this particular picture, you will see the force can change the shape as well as the size of the cars in this picture. I hope you are getting these things right. So these are all the examples along with the effects of force. Okay. Now we are heading into the next part, that is resultant force. So that is resultant force. What do you mean by a resultant force? The resultant force is defined as the total amount of force acting on an object or a body with the direction of the body. This is important. Along with the direction of the body. The resultant force is the total amount of force acting on an object or a body with the direction of the body. That is taken as resultant force. It is also called as net force. It is also called as net force. So, the net force or the resultant force is the force which is the total amount of it acting on an object along with the direction of the body itself. So that is known as resultant. Resultant force can be zero when an object or a body is at rest. When the object or a body is at rest, we can say that the resultant force acting on that body is zero. We have one more point, that is the resultant force again zero when the object is in uniform motion. When the object is in uniform motion, again the resultant force acting on the body is equal to zero and has some value. I am continuing that. Has this some value means resultant force having some value when the object is in other situations, which means other than the rest, other than the uniform state. So rest of the states are having some values for resultant force. Okay. Here I have an illustration, that is a book kept on a table. A book kept on a table here in this case. I can say this book is at rest. I can say easily that the book is at rest. The book which is at rest. When you say the object like book is at rest, the resultant force acting on that body is equal to zero. When the resultant force acting on that body is zero, then only we say that the book or any other object like that at rest. So here, what are the forces acting on this book? Remember, weight of the book is the one force. Weight of the book is the one force acting on it. And we have another force which is normal force we call, means this table offered an opposite force to the weight of the book, that is called as normal, or better you call reaction or reactive force you may call, that is R. So these are the forces acting on the book. Since weight and the reaction on the book are totally opposite, therefore which keeps the object at rest. So the resultant force is given by that is W, which is equal to R, W which is equal to R, and hence the resultant force acting on that is equal to 0. So since these two forces are equal and opposite, and one can say that the resultant force acting on this book kept on a table which is equal to 0. Remember, if these two forces are not equal, what happens? When these two forces are not equal, then we have say that it can be equal to resultant force is equal to some other value other than 0. You may call in that situation as a non-zero value. Okay. I hope you got the concept of resultant force right. And here, where do you find these kinds of forces? Why we consider the resultant force? Remember, whenever the object is at rest or object is in motion, there are so many forces acting on that body or an object. You can say that here in this example we have a couple of forces acting on the book. If the object is in motion, we can say that along with these two forces we have friction as well. So in such situations resultant force is required. That's the reason why I brought this term in. I hope you got this right once again. The next part, that is balanced and unbalanced forces. First one, that is balanced forces. When two or more forces acting simultaneously on a body. When two or more forces acting simultaneously on a body, the resultant force acting on it is 0. Such type of forces are known as balanced forces. So when two or more forces acting simultaneously on a body, the resultant force become 0, and hence such kind of force is known as balanced forces. In case of balanced forces, acceleration remains constant. So acceleration in this case becomes constant or sometimes 0. Okay. In case of balanced forces, I repeat, acceleration remains constant or sometimes 0. Okay. Let us illustrate, or let us give some illustrations for balanced forces. A book lying on the top of the table motionless. In the previous we kept the object like book at rest and hence on a table means. So that is also an example for balanced force. Why? The resultant force on that is equal to 0 and hence it is motionless. So this is the first example for balanced force. Here I am having the first example. So a book remain motionless when you place that on the table. So here there is a weight which is acting downwards and normal reaction to that, that is upwards, that is R. So these two forces keeps the book at rest as the resultant force acting on that is equal to 0 and hence such kind of force acting on that book is a balanced type of force. In the second case, or in the second example, in a tug of war game, the two teams apply the force on the rope. We all know that in a tug of war game, the two teams applying force on the rope in opposite direction. Assume the two teams are playing the tug of war game. The two teams apply same kind of force but in opposite directions. on the rope, if they pull with the same force, if they are applying same kind of force on the left side or right side, the resultant force on the rope remains constant. On the rope remains constant, and hence the picture appears to be still. That is another example for balanced force. Here in this picture, there are four members playing the tug of war game. So if you call this as team 1 or team A, you call this is team B. So team A and team B, if they are exerting same kind of force, say around 1000 Newton here, 2000 Newton here also, then the rope unmoved, and hence they are in stationary state, appears to be stationary state. So that is also an example for balanced type of force, or balanced force you may call. And in the third example, when the objects float on the water like ship, when their weight is balanced by the upthrust from the water. So you will come to know about thrust part later in the syllabus. So when the object floats in the water, the object floats means what? In this case, that is example as a ship. Ship is our object. Ship floats inside the water, that is balanced. Its weight W is balanced by the upthrust U. Upthrust U is balanced this particular ship, because weight of the ship is exerting is there actually, and upthrust provides the push up, and hence this is in balanced state. This is also an example for balanced forces. So objects like ship floats in the water when their weight is balanced by the upthrust from the water. The object will sink until the weight of the water it pushes out the way is the same as the weight of the object. This process goes on until the same weight is exerted by the water as well. That is called as upthrust. So weight and upthrust are balanced in this case, and hence one can say that is balanced force. I hope you got the concept of balanced force right. So next part, that is unbalanced forces. We all know that balanced force is the force when two or more forces acting simultaneously on the body. By that the resultant force is zero in that case. If it is not zero, then it is called as such types of forces called as unbalanced forces. When two or more forces acting simultaneously on the body, the resultant force changes. The resultant force is a non-zero element, then it is said to be unbalanced. Such forces are taken as unbalanced forces. In case of unbalanced forces, the acceleration differs. In balanced case, it is constant. In unbalanced case, that is different. Acceleration is going to differ, and hence we have different values of force. Okay. To illustrate unbalanced force, again make use of a tug of war game. In a tug of war game, so same picture is carried here. So I quoted earlier as this as team A and this as team B. Assume team A is exerting somewhat 1000 Newton and that kind of force, and on the other hand team B exerts 500 Newton. What happens? This team A is dragging 500 Newton to their side. Okay, so this is known as unbalanced force. Why? Team A is exerting much more pressure, much more force. The force of team A is greater than force on team B, and hence team A will going to win the match. Anyway, that is the example for unbalanced type of force. I hope you got that. In the second example, a truck speeds up in the direction of resultant force. A truck speeds up in the direction of resultant force. Okay, so here in this example we call it as unbalanced one because here this truck is having the bigger force of 100 Newton here, and the smaller force is on this side, and hence it will drag to its way. So if the truck is moving in this direction, it will carry this luggage, whatever it is having, on the same side, even though it is having some amount of force, comparably here 100 Newton that is exerted by the truck, and 60 Newton which is of the luggage, okay, or a good you may call. It will carry the luggage or goods to the direction of bigger force, and hence I can say the force or forces in this case are not balanced, and hence it is the example for unbalanced force. I hope you got all the points which I have discussed today. With some more concept, I am going to meet you in the next period. Till then, take care of yourselves. Bye bye.